Very good afternoon to all of you. Welcome back to the chemistry lecture. Hello guys, how are you? कैसे हो आप सब लोग? Hmm? So today we will start our chapter number one actually, that is chemical kinetics, which is very important chapter as far as your SY BSc chemistry paper is concerned. Okay, this chapter is very important. Most of the questions are based on this chapter. Okay, so this chapter in the chemical kinetics we will discuss something about uh, kinetics of the reaction. Nutan is saying fine sir. Okay, chalo. So Abhishek is also saying good afternoon. Good afternoon, Abhishek. So today we will start this chemical kinetics chapter, that is chapter number one. In this lecture, we will see, first of all, we will see the introduction. What is chemical kinetics? What is this chemical kinetics means? Then we will see the rate of chemical reaction. Then we will see Rupesh Kumar Yadav. Good afternoon, Rupesh Kumar. Then we will see the rate of reaction, rate law we will see, law of mass action we will see. Then we will see the order of reactions. So there are some orders of chemical reactions. So what is this order? How to determine order? That we will see. Then we will see Akansha Chauhan. Very good afternoon. Then we will see molecularity of reaction, and we will see some factors which affects the rate of reaction. Then we will see the zero order reaction, first order reaction, second order reaction. Then we will see activation energy, collision theory, and in the last we will see the collision theory. So this is the topics or subtopics of chapter number one, that is chemical kinetics, that we are going to discuss in this chapter. Okay. So shall I start the lecture? Shall I start the lecture now? It's almost 2:20. Shall I start the lecture? Please reply me. Amisha, very good afternoon. Rupesh is saying yes, sir. So, okay, we will start today's lecture. I think yes, Chaitanya, Anjes, Tanishk is also saying yes, sir. Okay, Amisha is also saying yes, sir. So, this is your lecture number one of chemical kinetics. Okay. Okay, so in this lecture, we will start with the introduction. So, this chemical kinetics, this word, have you heard this word? Chemical kinetics? So, this word is related to the rate and mechanism of a chemical reaction. So, we will discuss kinetics of a chemical reaction. Kinetics means the rate of chemical reactions, speed of chemical reaction we will discuss, velocity of chemical reaction we will discuss. So, these chemical kinetics and chemical thermodynamics, two different we can say branches of physical chemistry. So these chemical kinetics and chemical thermodynamics, they are related to the different things. So what is mean by chemical kinetics, what is mean by thermodynamic, or this chemical kinetics or rate of a reaction depends upon which thing. Then chemical thermodynamics, that means thermodynamics, it is related to what? Thermo means what? Thermodynamics what? Anybody know what the meaning of thermodynamics? Have you heard this word? Thermodynamics. What is the meaning of this word? Thermodynamics. I have told you, chemical kinetics is related to the rate, velocity, speed of reactions. Yes, Pramodini, very good. Thermodynamics, heat. It is related to temperature or heat of the reactions. Or now we will discuss, we will see what is meant by chemical thermodynamics and what is meant by chemical kinetics. So, have you seen this, what we can say, energy profile diagram of chemical reactions? For example, suppose this is your y-axis and this is your x-axis. On y-axis, energy is there, E is there, and on x-axis reaction coordinates are there. Reaction coordinates are there. For example, suppose here your reactants are there. This is your reactants, and here products are there. Here products are there, and this reaction goes and it forms a product. Now this part or this peak is called as, can anybody knows what is this peak? क्या बोलते हैं इसको, this peak को? This peak is called as what? Anybody knows this peak? Here at the starting reactants are there and end products are there, and generally reactants are having higher energy than the products. Products are always lower in energy. Ionization, no, that peak is not called as ionization. So reactants are higher in energy, products are lower in energy. Okay, and this peak is called as what? This peak is called as transition state, TS. Correct. This peak is called as a transition state. It is also called as a short form, it is TS. Then it is also called as activated complex. Activated complex. Okay. So this peak is called as a transition state, TS, and activated complex. Now this energy difference between this reactant and this TS, energy difference between reactant and TS is called as activation energy. This energy difference, activation energy. Energy difference between reactant and transition state, it is called as activation energy, and this activation energy is denoted by delta E, or it is also called as a energy of activation. This delta is also called as energy of activation. And now this energy, the energy difference between product and a reactant, now this to this energy, reactant to product, this energy is called as a reaction energy. This energy is called as reaction energy. Okay, understood this. Now this reaction energy is related to the thermodynamics. The reaction energy is related to the thermodynamics, and this energy of activation, it is related to kinetics. Kinetics. Now understood, the activation energy which is related to the kinetics, or this kinetics or rate of reaction is depends upon the activation energy, and thermodynamic stability is depends upon the reaction energy. Rate or kinetics, rate of the reaction is depends upon the activation energy, and thermodynamic stability is depends upon the reaction energy. Now higher the activation energy, that means what? That means reactants to go to the or to form an activated complex, the energy requires high. Higher energy will be required for the transitions, formation of transition state when the activation energy is high. So greater the activation energy, please write down this, greater the activation energy, slower will be the rate of reaction. Greater the activation energy, slower will be the rate of reaction. Okay, so activation energy and rate of reaction, they are inversely proportional to each other. Activation energy, that is delta E, is inversely proportional to the rate of reaction, velocity of reaction or speed of reaction. Okay, and this reaction energy, higher the reaction energy, higher will be the thermodynamic stability. Higher the reaction energy, higher will be the thermodynamic stability. So this reaction energy is directly proportional to the thermodynamic stability of that product. Reaction energy is directly proportional to the thermodynamic stability, while activation energy is inversely proportional to the kinetics of that reaction. Now have you understood the difference between chemical kinetics and chemical thermodynamics? If yes, then we will go to the next point. Okay, so क्या है? Have you understood this? So next point is the definition of rate. How will you define a rate? How will you define a speed? How will you define a velocity of reaction? Can anybody tell? Can anybody tell me how will you define a rate of reaction or speed of reaction? Generally, this rate and speed and velocity is related to the time. Rate and velocity is related to the time. Ganesh is saying yes, sir. Okay, chalo. So this rate is always related to the time. So we'll see the first definition of rate. What is the rate? What is the speed of reaction? What is the velocity of reaction? Okay? That we will see. So if you have pen notebook, you can write down the definition of rate. So you may write down or listen carefully what is the definition of rate. See here, the rate of a chemical reaction is defined as decrease in concentration of a reactant. What is rate? Rate is defined as, rate is nothing but decrease in concentration of a reactant in a unit time. Reaction carried out versus time. Correct. The area is saying reaction carried out versus time, or it is related to the concentration of reactant. It is related to the concentration of reactant. What happens? For example, see this reaction, or A goes to B. So here A is reactant. Sorry. A is reactant and this B is product. So what happens? The concentration of A goes on decreasing as time goes on. क्या होता है? जैसे जैसे reactions proceed होती है वैसे वैसे क्या होता है? Concentration of reactant decrease होता है and concentration of the product, that is B, is increases. So this definition of rate is nothing but the decrease in concentration of a reactant in unit time or increase in concentration of a product in unit time. This is the definition of rate. Write down this definition. The rate of chemical reaction is defined as the decrease in concentration of a reactant in unit time or increase in concentration of a product. Product का concentration क्या हो रहा है? Increase हो रहा है and reactant का concentration क्या हो रहा है? Decrease हो रहा है. ठीक है? So this is the definition of rate. For example, I have told you reactant. Let us consider this A goes to B. This is your reactant. This is your reactant and this is your product. So mathematically, how will you write this rate of this reaction? How will you write mathematically the rate of these reactions? The rate of chemical reaction equals to nothing. We have seen this. Rate of chemical reaction equals to rate of disappearance of reactant A. Rate of reaction equals to rate of disappearance of reactant A. Now why disappearance of reactant A? उसका concentration क्या हो रहा है? Decrease हो रहा है. And at what time? What will happen? All the reactant, they will get disappear and there will be formation of product takes place. So that's why disappearance word is there. So what happens in this during the course of reaction? Concentration of reactant A goes on decreasing and concentration of product B goes on increasing. So mathematically, how will you write? See here, rate of reaction with respect to reactant A. Rate of reaction with respect to reactant A, negative sign. Negative minus D concentration of A upon dt. So why D upon dt? Because small change is there. Why D upon dt? Because small change is there. And why this negative sign is there? Because concentration of A is decreases. Concentration of A is decreases. उसका concentration क्या हो रहा है? कम हो रहा है, minus हो रहा है. That's why the negative sign is there. So mathematically we can write with respect to reactant A is equals to negative or minus D concentration of A by dt. Now this is the rate of reaction with respect to the reactant A. Now we will see the rate of reactions with respect to the product B. Rate of reaction is equals to rate of appearance of product B. Why? Because product क्या हो रहा है यहाँ पे appear हो रहा है. That's why appearance word is there. So rate of reactions with respect to product B is equal to rate of appearance of product B is equals to, see the mathematical expression, B is equal to D concentration of B by dt. Here no negative sign, here plus sign is there. No negative sign, plus sign is there. Why plus sign is there? Because concentration क्या हो रहा है? Increase हो रहा है, addition हो रहा है ना product में. That's why positive sign is there. ठीक है, understood? Definition of rate, yes or no? अगर आपको समझ में आ रहा है तो we will see the examples. How to write a rate of reaction? How to express the definition of rate into an equation? How will you write that definition in equation form? That we will see in these two examples, example number 2 and example number 3. If you understood the definition of rate, how to write a rate with respect to reactant and with respect to product, while writing the rate of reaction with respect to the reactant, you have to always give a negative sign, and while writing the rate of reactions with respect to the product, you have to give a plus sign. Please remember this. Rupesh Kumar is saying yes sir, Nutan is also saying yes sir. Okay, so we will go to the example now. We will go to the example now. Now see the example number 2. Now here two reactions are there. Kya hai? In first reaction only one reactant was there. Here two reactants are there. Reactant A, this is your reactant A, and this is your reactant B. So this reactant A plus B gives you C. C is product. Reactant A plus B gives you B, and this 2 moles of A is there. Stoichiometric, this 2 is called as a stoichiometric coefficient. 2 is called as what is this 2? It is called as a stoichiometric amount of A, or it is also called as a stoichiometric coefficient. So 2 moles of A plus 1 mole of B gives you 1 mole of C. This is your reaction, generalized reaction. Yeah. So how will you write the rate of this reaction? How will you write rate of this reaction? See here, the rate of reaction is equal to, with respect to reactant A, I am talking about with respect to reactant A. So minus, negative sign is there, negative. So number of moles, please remember this, number of moles you have to always write in a denominator side. Okay, so minus 1 by 2 dA by dt. D concentration of A. This square bracket means concentration of A. This square bracket means concentration of A. Please remember how to read this, concentration of A. If A is in square bracket, how will you read this? Concentration of A. So please remember this stoichiometric amount of A or stoichiometric coefficient of reactant, you have to always write in denominator side. So negative sign, why negative sign is there? Because rate of or concentration of A is decreases, that's why negative sign is there. And stoichiometric amount or stoichiometric coefficient you have to always write in denominator side. And d by dt means what? There is a small change in concentration, because we are calculating the rate of reactions at any instant. किसी भी time पे हम लोग उसको rate of reaction calculate कर सकते हैं. So d by dt is small change is there. So d concentration of A upon dt. This is the rate of reactions with respect to the reactant A. This is the rate of reaction with respect to reactant A. Now we will see the rate of reaction with respect to the reactant D. क्या है? B is equal to negative sign because concentration of B is decreases. D concentration of B minus dt. Very simple. D concentration of B minus dt. So this is the reactant. This is reactant A and B. These are the two reactants of this reaction. Now we will write the rate of reactions with respect to the product, that is C. So here C is equal to D concentration of C by dt. In here no negative sign means plus sign is there. And why plus sign is there? Because the concentration of C is increases. क्या हो रहा है? C is appearing in the product side, that's why positive sign is there. So this is your example number 2. Then example number 3. Then example number 3. A of A plus B of B gives you C of C and D of D. This capital A, B, they are reactant, and capital C, D, they are product. small a and b, they are stoichiometric coefficient of reactant A and B respectively, and this small c and d, these are stoichiometric coefficient or stoichiometric amount of the product C and D respectively. Okay, so these A, B, C and D, they are stoichiometric amount of reactant product respectively. Okay, so for this reaction you have to write the rate of reaction. For this reaction you have to write the rate of reaction. Now see how will you write rate of reaction with respect to reactant A. Rate of reaction with respect to reactant A minus, here stoichiometric coefficient of reactant A is small a. So this small a you have to write in denominator side, minus 1 by A d concentration of A by dt. Then with respect to reactant B, minus 1 upon B d concentration of B upon dt. So these are two reactant. Now we will see the rate of reaction with respect to the product C. Here C, 1 upon C, no negative sign is there because these are the rate of reaction with respect to product. So 1 upon C d concentration of C by dt, and last reactant D 1 upon d concentration of D by dt. So in this way you have to write the rate of reaction. So in this way you have to write the rate of reaction. Understood? Have you understood this? Yes or no? Then we will see the unit of reaction. आप लोगों को समझ में आया है क्या हाउ टू राइट द रेट ऑफ रिएक्शन? How to write rate of reactions? Have you understood this? Yes or no? Please tell me. If you have any problem, any doubt, you can ask me right now. Then we will see the unit of rate. Pramodini is saying yes sir. What about others? Vaibhav is also saying yes sir. Vaibhav la पण समजले. Pramodini, Vaibhav, Madhukar. Okay, Sabha is also saying yes sir. Okay, so that means you have understood. Then we will see the unit of rate. We will derive the unit of rate. Rupesh Kumar is also saying understood sir. Akansha Chavan is also saying yes sir. So we'll okay, Sandesh is also saying yes sir. Tanishk. So next point is unit of rate. So how will you give the unit to the rate, or we will see how to derive the unit of rate. So here if you see here, this is rate with respect to reactant C. Okay, this is your rate. Now D concentration of C. So here concentration term is there and here T is there. So concentration upon time. This is your unit. The unit of rate is concentration upon time. It's very simple. Concentration upon time. Now here generally concentrations are expressed in moles per liter. Generally concentrations are expressed in moles per liter, and time is generally expressed in second. So this is the unit of rate. Moles per liter per second. This is the unit of rate. See here, the unit of rate of reaction is moles per liter per second. So this is the rate, unit of rate when the reaction in solution or liquid state. When the reaction is solution and liquid state. One more unit is there, mole per centimeter cube per second. Centimeter cube is used when the reaction takes place in gaseous state. When this moles per centimeter cube is used when the reaction is in gaseous state, and moles per liter, liter means it is a unit of liquid, it is a unit of solution. Okay, so when you have to use moles per liter per second when reaction takes place in solution state, and when you have to use moles per centimeter cube per second when the reaction takes place in gaseous state. So these are the unit of rate. Now we will see the rate law. Next point is rate law. First we will see the definition of rate law. If you have pen, notebook, you can write down this definition of rate law. क्या है definition of rate law? The rate of a chemical reaction at any time. The rate of chemical reaction at any time. You can calculate the rate of any chemical reactions at any time. Please remember this. The rate of chemical reaction at any time is directly proportional to the molar concentration of reacting substance at that time. What is the rate law? Rate law is nothing but the rate of chemical reaction at any time is directly proportional to the molar concentration of reacting substance at that time. Write down this definition. The rate of chemical reaction at any time is directly proportional to the molar concentration of reacting substance at that time. So what is the rate? Rate is directly proportional to the molar concentration of reactant. What is rate? Rate is directly proportional to the molar concentration of reactant. And whatever the time is there, that time you have to keep in mind. Okay? Now we'll see the reaction. For example, this reactant A, it goes or it forms a product. So this is A is your reactant. A is your reactant. And for this reaction, or according to the law of mass action, the rate at time t, for example, this rate at time is directly proportional to the reacting substance. And in this, is it proportional to the biomolecular substrate also? That we will see. Here, just in biomolecular substrate, there are different factors are also there. So we will see for only general reaction, A goes to B. Okay, that we will see in the maybe in TYBSc, that we will see. Okay, for this it is only a simple chemical reaction. Two reactants are there, and it will give you a product. So according to the law of mass action, rate at time t is directly proportional to the reacting substance, and in this reaction, reacting substance is A, which is only one reactant. So according to law of mass action, rate at time t is directly proportional to the molar concentration of reactant T. So this A is nothing but molar concentration. A is nothing but, what is this A? A is nothing but the molar concentration. So according to the law of mass action, rate at time t is directly proportional to the molar concentration of a reactant A. Now how will you write? You know that now rate is equal to, here rate is equal to minus, because why? We are writing this rate is equal to with respect to the reactant. So concentration of reactant is decreases, that's why negative sign is there. The molar concentration of A by dt is directly proportional to the concentration of A. So this is the rate law. This equation is called as a rate law. Rate is equal to minus the concentration of A by dt, which is directly proportional to the concentration of A. This equation is called as a rate law. Now let us consider one more reaction. Now here in this first reaction, only one reactant was there. Now here two reactants are there. Reactant A and reactant B. So in this reaction, that is reactant A plus B gives you product. So in this to this reaction, we will apply law of mass action, and we will write down the rate. So here, according to the law of mass action, rate at time t, rate at time t is directly proportional to the reacting substance. Now here reacting substances are two, A and B. Two reactants are there. So rate at a time t, according to the law of mass action, rate at a time t is directly proportional to the molar concentration of reactant A and molar concentration of reactant B. So we'll write down in the equation form, rate is equal to minus the concentration of A by dt is directly proportional to the molar concentration of A into, please remember this, you have to multiply this, A into B. So is directly proportional to the molar concentration of A multiplied by molar concentration of B. So if you multiply whatever the reactants are there, that reactants you have to multiply. Please remember this, reactants you have to multiply. So one more reaction is there. Here now two reactants are there, reactant A and reactant B. Here stoichiometric amount of reactant A is 1 and stoichiometric amount of reactant B is 2. So this 1A plus 2B gives you product. This is your reaction. 1A plus 2B gives you product. So this reaction we will apply law of mass action, and we will write down the rate. So according to the law of mass action, the rate at a time t is directly proportional to the molar concentration of reactant A into molar concentration of reactant B, and whatever the stoichiometric coefficient is there or stoichiometric amount is there, you have to write down at the power. You have to write down that at a power side. So according to the law of mass action, rate at a time t is directly proportional to the molar concentration of reactant A multiplied by molar square of molar concentration of reactant B. This is the rate law. This is the rate law. And how will you write this equation? This equation, rate is equal to negative. Why negative? Because concentration of reactants are decreasing. So d concentration of A by dt is directly proportional to the molar concentration of reactant A into molar square of molar concentration of B. This equation is called as a rate law. This equation is called as a rate law. Understood what is rate law? Understood what is rate law? Then we will apply this rate law to a general reaction. Consider this is a general reaction. This is your general reaction. That is A of A plus B of B gives you product. Here capital A and capital B are reactant, small a and small b. These are the stoichiometric coefficient or stoichiometric amount of reactant A and B respectively. Okay, Ganesh, Vaibhav, Rupesh is saying yes sir. So for this reaction, A of A plus B of B gives you product. We will apply a rate law. So according to the rate is directly proportional to molar concentration of A into molar concentration of B, and you have to put the stoichiometric amount at the power side, A plus B here. Okay, so in this way you have to write down the rate. Now here, now if I want to remove this directly proportional sign, you have to remove this directly proportional sign. This rate is generally written by a small r. Please remember this. Rate is generally written by a small r. So this r is equal to, now I want to remove this proportionality sign. So if I want to remove this proportionality sign, I have to put the proportionality constant k. I have to put a constant there. So r is equal to proportionality constant k into molar concentration of A into molar concentration of B, and you have to give the stoichiometric amount at the power side. So this K is called as, what is this K? This K is called as a proportionality constant, or it is also called as a rate constant. So this K is nothing but rate constant. K is nothing but rate constant. Okay? K is nothing but the rate constant. Now if you know the molar concentration of A, molar concentration of B at a time t, and you know the rate constant, then you can find out the rate of reaction. You can find out the rate of any reactions. If you know the molar concentration of reactant A and molar concentration of reactant B, and you know the proportionality constant or rate constant, then you can find out rate of any chemical reaction. Okay? Now we will see the examples. This is your example. 2HI, that is hydroiodide, HCl, HBr and HI is there. So 2HI gives you H2 plus I2. 2HI gives you H2 plus I2. So R is equal to, how will you write this? R is equal to proportionality constant K, then molar concentration of reactant. So here only one reactant is there, HI is there. So molar concentration of reactant HI, and you have to give the power side. So R is equal to K HI and square. So in this way you will write the rate R is equal to. Now example number 2. For these reactions, NaOH plus CH3Br gives you CH3OH plus NaBr. So sodium hydroxide plus methyl bromide gives you methanol plus sodium bromide. So in these reactions you have to write down, R is equal to. You people write down R is equal to, and how will you write R is equal to? Write down this. reply me in chat section. R is equal to, how will you write this? Rate is equal to, for this reaction, NaOH plus CH3Br gives you CH3OH plus NaBr. Sodium hydroxide plus methyl bromide gives you methanol plus sodium bromide. And to these reactions you have to apply the rate law. You have to apply the rate law. R is equal to K into what? R is equal to K into, yes, how will you apply this rate law to this reaction? Simple, eh? According to the rate law, the rate of chemical reactions at a time t is directly proportional to the molar concentration of reacting species or reacting substances. So here reacting substances are NaOH and CH3Br. So just you have to write R is equal to K. No, R is equal to K Newton. Correct. R is equal to K into molar concentration of NaOH into molar concentration of CH3Br. Correct, Madhukar, Rupesh Kumar Yadav, very good. Rate is equal to K into NaOH, molar concentration of NaOH plus molar concentration of CH3Br. So how will you write? K is equal to, correct, very good. K is equal to molar concentration of NaOH. Why NaOH? Because it is reacting species, into molar concentration of CH3Br. CH3Br, very simple, because these two are reactants. See here, K is equal to, R is equal to K into NaOH plus CH3Br. Okay. Okay. And just very good. Then we will see the order of reaction. Next point, which is very important point, order of reaction. So give the heading. If you have notebook, write down this order of reaction. We will see the definition first. हम लोग क्या देखेंगे? Definition of order of reaction, that we will see. So what is the definition of order of reaction? The order of a reaction with respect to a particular reactant is equal to the power to which the concentration of that reactant is raised in experimentally determined rate equation. In experimentally determined rate equation. Now see this word, experimentally determined rate equation. So that means this order of reaction is based on experimentally determined rate equation. So this order of reaction is experimental quantity. Please remember this. So क्या है? The order of reaction with respect to a particular reactant. Order, we can write down order of reaction to a particular reactant also, and we can calculate, or we can write down the overall order of reaction also. So order of reaction with respect to a particular reactant is equal to power to which the concentration of that reactant is raised in experimentally determined rate equation. So first you have to determine rate equation experimentally. That means you have to perform a experiment, and after the experiment you have to write down the rate of reaction, and after write down the rate equation you can find out the order of reaction. So this is the definition of order of reaction. Write down this definition. क्या है? The order of reaction with respect to a particular reactant is equal to the power to which the concentration of that reactant is raised in experimentally determined rate equation. This is the definition of order of reaction. Then the next comes is overall order. Next क्या है? Overall order. The overall order of reaction involving two or more reactants is the sum of the powers of concentration of various reactants involved in the rate equation. And this rate equation must be experimentally determined. Didn't understand 100%, will explain the definition in Marathi. Madhukar, don't worry. We will take example. After taking example, we will understood what is the definition of order of reaction. Don't worry about that. After taking example, I will explain this definition once more. Okay. So first of all, please remember, order of reaction you can write with respect to a particular reactant. For example, 2 or 3 reactants are there. You can write down the reactant with respect to reactant A, with respect to reactant B, with respect to reactant C. Okay, or you can write down the overall order with respect to reactant A plus B plus C also. How? That we will see while discussing the examples. So next point you have to write down is overall order. Next point you have to write down is overall order. The overall order of reaction involving 2 or more reactant. For example, if the reactant is only one, in that case, if the reactant is only one, in that case, overall order and order of reaction with respect to a particular reactant is same. अगर अगर reactant एक ही है तो उसकी overall order and order with respect to that particular reactant will be same. And अगर the reactance is more than 2 or more than 1, अगर आपके reactant more than 2 है, more than 1 है, तो उस केस में क्या हो जाएगा, overall order and order with respect to that particular reactant will be different. वो कैसे हम लोग देखेंगे while solving the problem. So next point, please write down this point. The overall order of reaction involving 2 or more reactant is the sum of the powers of concentration of various reactants involved in the rate equation. Write down this. Then next point, the order of reaction. Next point is क्या है? The order of reaction is an experimentally determined quantity. I have already told you. क्या है? यहाँ पे मैंने बोला था experimentally determined rate equation. So while calculating the order of reactions, you have to first write down a rate equation, and that rate equation must be experimentally determined. और rate equation कैसे होना चाहिए? Experimentally determined होना चाहिए. So the order of reaction is an experimentally determined quantity. It is obtained from the rate equation. कहाँ से आ जाती है वो order of reaction? It is obtained from the rate equation applicable to the reaction. ठीक है? So this is the order of reaction. Now let us see this reaction. Let us see these reactions. N1 of A plus N2 of B plus N3 of C. They combines and forms a product. They gives you a product. Now here capital A, capital B, capital C, these are the reactants. क्या है वो? आप लोगों के reactants है. Capital A, capital B, capital C, these are the reactants. And N1, N2, N3, these are the stoichiometric coefficient of reactant A, reactant B, reactant C respectively. So now I will write down the order of reactions with respect to reactant A. So with respect to reactant A, order of reaction is N1. With respect to C here, with respect to a particular reactant here I have taken is A. So with respect to reactant A, order of reaction is N1. With respect to reactant B, order of reaction is N2. And with respect to reactant C, order of reaction is, tell me, with respect to reactant C, order of reaction is क्या है? With respect to reactant C, the order of reaction is, please reply me in chat section. Correct, very good Pramodini. With respect to reactant C, order of reaction is N3. Akansha, Sabha, all are saying N3. That means you have understood what is the order of reaction to a particular reactant. So here order of reaction with respect to reactant C is N3. So I will write here N3. Now what is overall order? N is equal to N1 plus N2 plus N3. So this is your overall order. See here. This is your rate equation. This is your rate equation. R is equal to K, concentration of A, N1
into concentration of B N2 into concentration of C N3. So this is your rate equation. Please remember this. Sorry, I have forgot to write rate equation first. First you have to write down the rate equation. So this is your rate equation and this is your order of reaction with respect to reactant A, with respect to reactant B and with respect to reactant C, that is N3. And what is the overall order? Overall order is nothing but small n is equal to N1 plus N2 plus N3. This is your overall order. So overall order of the reaction N is equal to this N1, N2 plus N3. Now we will see some example. Now we will see some example. Example number 1. Example number 1. So here 2NO plus O2 gives you NO2. So these are your reactant. ये आप लोगों के क्या है reactants and this is your product. So what you have to do first? क्या करना है आप लोगों को first? First what you have to do? Please tell me. What you have to do first? To find an order of reaction, what you have to do first? आप लोगों को सबसे पहले क्या करना है? Order of reaction, rate of reaction और rate equation लिखना है आप लोगों को. Correct. First write the rate equation. First write the rate equation. So rate equation R is equals to, here rate equation R is equal to क्या है? K no rate of reaction, you have to write rate of equation. Please remember this. Rate equation लिखना है अपना. K into molar concentration of NO into molar concentration of O2, and here stoichiometric amount of NO is 2, so give the, write down that 2 at the power side. So this is rate of reaction. That means the concentration of NO and concentration of O2, they are involving a rate equation. They are involving rate equation. So how will you write the order of reaction? How will you write the order of reaction? Here the power is 1. कुछ भी नहीं, that means power is 1. So here you have to write down n is equal to n1 plus n2. n is equal to n1 plus n2. So n is equal to n1 क्या है 2 plus n2 क्या है 1. So order of reaction is 3. So in this way you have to write down the order of reaction. In this way you have to write down the order of reaction. See here rate equation. Here rate equation R is equal to K into molar concentration of NO square into molar concentration of A2, and order of reaction is 3. Order of reaction is 3. Because of why 3? I have told you. N is equal to N1 plus N2. Here N1 is 2 and N2 is 1. So 2 plus 1 overall order of reaction is 3. Understood? Yes or no? Understood this? How to find the order of reaction? Now this is example number 2. This is example number 2. Yes, everybody is saying yes, sir. This is example number 2. Now tell me the order of reaction for this example number 2. Tell me the order of reaction for example number 2. Sneha, Nutan, Ganesh, Chaitanya, they are saying yes, sir. Okay. Now tell me the order of reaction for example number 2. Order of reaction is 3 plus 1 is equal to 4. Correct? Rahul, Anjesh, they are saying correct. Order of reaction is 4 because because 3 and here 1, so 3 plus 1 is 4, so the order of reaction is 4. Sorry, the expected order of the reaction is 3 plus 1 is equal to 4. This is our expected order. Please remember this. This is kya hai? Expected order of reaction is 4, but the order of reaction for this reaction is not of 4. The order of reaction for this reaction is not of 4. How? Kaise nahi hai, that we will see. Here, this is your overall reaction, but actual this reaction not takes place in only one step. ये KClO plus O2 gives you KClO3 plus 2 KCl. This reaction does not take place in one step. There are different steps. So first step is only 2 KClO, only 2 KClO they undergo a decomposition to form KClO2 plus KCl. This is your first reaction, and second reaction is this KClO2 and 1 KClO they will get react and forms KClO3 and KCl. So this is one step reaction, but actually this reaction does not go, or it is not a one step reaction, it is a two step reaction. This is step number 1 and this is step number 2. So in the first reaction 2 KClO3 they undergo decomposition gives you KClO2 plus KCl, and step number 2 this KClO2 reacts with remaining KClO gives you KClO3 and KCl. So out of this second reaction is fast reaction. Second reaction is fast reaction and this first reaction is slow reaction. So step number 1 is very slow and step number 2 is fast reaction, and according to chemical kinetics the slowest step is rate determining step. Slowest step is called as a RDS. This R stands for rate, this stands for determining, and S stands for step. So this slowest step is rate determining step. Slowest step is rate determining step, and while writing the rate equation you have to consider RDS only. While writing rate equation you have to consider RDS only, that is rate determining step. And according to this slowest step number 1, how will you write the rate of reaction? K is equal to R is equal to K into molar concentration of KClO square. Molar concentration of KClO square. So this is your rate equation for this reaction. R is equal to K molar concentration of KClO square. So why only you have to consider this step? Because this is a rate determining step, and while writing the rate equation you have to consider only rate determining step, not a fast step. आप लोगों को fast step से कोई लेना देना नहीं. You have to consider a slowest step. That slowest step is called as a rate determining step, that is RDS, and you have to write down the rate equation according to the RDS. And rate equation according to the RDS is R is equal to K molar concentration of KClO3 square. Now tell me the order of reaction. Now tell me order of reaction. What is the order of reaction? Now tell me the order of reaction. What is the order of reaction? What is the order of reaction? Correct. Order of reaction is 2. Order of reaction is 2. So Nutan, Abhishek, Rupesh Kumar, very good. So according to the rate equation now, Santosh is also saying 2. According to the rate equation now, the order of reaction is 2. According to the rate equation, order of reaction N is equal to 2. So because of this only, this order is experimentally determined quantity. It is not a theoretical quantity. It is an experimental quantity. Now why it is experimental quantity? Because after performing experiment, you could know this is a slow step and this is a fast step. एक्सपेरिमेंट करने के बाद ही आप लोगों को पता चलेगा कि which is a rate determining step. Rate determining step is always the slowest step of the reaction, and after the experiment that will come to the know. So because of this, order of reaction is an experimental quantity. Because of this, order of reaction is experimental quantity and it is not a theoretical quantity. Understood why order of reaction is experimental quantity and why it is not a theoretical quantity? Understood this? ये एग्जाम्पल आप लोगों को ध्यान में रखना है. दैट इज 3 KClO plus O2 gives you KClO3 plus 2 KCl. ठीक है. So please remember this, order of reaction is not a theoretical quantity, it is a experimental quantity. चलो, then we will see the next one. So order of reaction here is 2. हम लोगों ने अभी कैलकुलेट किया है. Order of reaction is 2. Okay. Then points to remember. 3 points are there that you have to remember in case of order of reaction. Write down these points to remember. Write down these points to remember. क्या है first point? In the rate equation. The first point is, in the rate equation only those reactants appears whose concentration undergoes a measurable change during the reaction. Now to find out the order of reaction you have to write a rate equation. आप लोगों को क्या करना होता है? सबसे पहले आप लोगों को रेट इक्वेशन लिखना होता है टू फाइंड एन ऑर्डर ऑफ रिएक्शन. सो इन रेट इक्वेशन विच टर्म विल बी अपीयर? कौन से टर्म आ जाएंगे रेट इक्वेशन में? दोज रिएक्टेंट्स. कौन से रिएक्टेंट आ जाएंगे? ओनली दोज रिएक्टेंट्स हु अपीयर्स, और जिसका कॉन्सेंट्रेशन चेंज है ना वो मेजरेबल होता है. किसका? जिस रिएक्टेंट का concentration change of concentration is measurable, only that reactant will appear in a rate equation. This is the first point you have to remember. In the rate equation, क्या है? In the rate equation only those reactants appears whose concentration undergo a measurable change during the reaction. This is the first point. Second point क्या है? The reactants, second point is the reactants which are present in large concentration. The reactants which are present in large concentration will not appear in the rate equation. Because of what? Because of the changes in their concentrations are very small. अगर change in concentration बहुत ही small है ना, in that case also that reactants will not appear in the rate equation. The reactants which are present in large concentration, that reactants will not appear in the rate equation. Because of what? Because of large concentration their change in concentration is very small. Because their change in concentration is very small, such term or such reactants will not also appear in the rate equation. That point you have to remember. Point number 2. Then we'll see the point number 3. The catalyst term will also not appear in the rate equation. The catalyst term will also not appear in the rate equation. Because of this catalyst, it does not take parts in the equation. Catalyst, it actually does not take part in the equation, or in some equation it may take part in the reaction, but at the end of reaction its concentration will remain same. At the end of reaction what will happen? Its concentration will remain so due to this also the catalyst term will also not appear in the rate equation. These 3 points you have to remember. In the rate equation, first point, in the rate equation only those reactants appear whose concentration undergo measurable change. Then second point, the reactants which are present in large concentration will also not appear in the rate equation. And the third point is the catalyst term will also not appear in the rate equation. These 3 points you have to remember while determining the order of reaction. ठीक है, understood? Okay. Then next we will see the molecularity of reaction. Next we will see molecularity of reaction. First we will see the definition. The number of reactant, write down this definition. The number of reactant molecules that are involved in an elementary step represent the molecularity of an elementary reaction. What is molecularity of reaction? The number of reactant molecules that are involved in an elementary step that represent the molecularity of that elementary reaction. The order and molecularity of such reactions are same. The order and molecularity of such reactions are same. Then the next point is the molecularity is a theoretical quantity. Please remember this. The molecularity is a theoretical quantity, while order of reaction is not a theoretical quantity. Order of reaction is an experimental quantity, and molecularity is theoretical quantity, and it is based on the mechanism of the reaction. Molecularity is theoretical quantity and is based on the mechanism of the reaction. Then third point, the slowest intermediate step decides the overall rate of reaction. This step is called as a RDS, that I have already told you. The slowest step is called as a rate determining step, that is RDS. Then we will see the difference. We will see the difference between molecularity and order of reaction. हम लोग क्या देखेंगे, difference देखेंगे, and in the next lecture we will see the examples of molecularity also. In the next lecture we will also see the examples. Now first we will see the difference between order and molecularity. What is the difference between these two terms? So you may write down order and molecularity and write down the difference. First difference is क्या है? First difference, in case of order, order of reaction, it is the sum of powers of concentration of reactants involved in the rate equation. क्या है order of reaction? You have to write the first point, always you have to write down the definition. क्या है definition of order? It is the sum of powers of concentration of reactants involved in the rate equation. This is the definition of order. And what is the definition of molecularity? It is the number of reactant molecule involved in an elementary step. This is the first difference. First difference, always you have to write down the definition. Then second difference, order of reaction is an experimentally determined quantity. Order of reaction is an experimentally determined quantity, while molecularity of reaction is a theoretical quantity. Then order of reaction can be fractional and can be zero. Order of reaction, third point in the order of reaction is it can be fractional, that is order of reaction can be fractional and can be zero, while molecularity it cannot be fractional and cannot be zero. Molecularity of reaction here cannot be. Molecularity of reaction, it cannot be fractional and cannot be zero. Then fourth point in case of order, it can be changed with experimental condition like concentration and pressure. Order can be changed with experimental condition. Please remember this. And which consider changes the order, which condition changes the order of reaction, such as concentration of the reactant and pressure of the reactants. These two terms can change the order of reaction, while molecularity does not changes with the experimental condition. Molecularity does not changes with the experimental condition. It is independent upon experimental condition like concentration and pressure. Order of reaction changes with experimental condition. Molecularity does not changes with experimental condition. So this is today's lecture. I think we will stop here. Remaining part we will see in the next lecture. If you have any problem, any doubt, you can ask me. I will give 5 minutes for that. If you don't have any problem, then it's fine.